I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We now discuss the solutions of three problems from the section Partial Differential Equations from the question papers of CSIR National Eligibility Test held on December 15, 2019. These questions are suitable for all these examinations. Right. This is the question from Part C carrying 4.75 marks with this question ID. The question is related to Cauchy's problem. The given question is a possible initial strip x0, y0, z0, p0, q0 for the Cauchy problem pq is equal to 1, where p is del z by del x, q is del z by del y. And the initial data given as x naught s is equal to s, y naught of s is 1 by s, z naught of s is 1 for s greater than 1 is. We are given 4 options. In all these options, the first 3 components are s, 1 by s and 1. In option 1, the 4th and the 5th option, 4th and 5th entries are 1 by s and s. In option 2, it is minus 1 by s and minus s. In option 3, it is 1 by s, comma minus s. In option 4, it is minus 1 by s and s. Let us now discuss the solution of the problem in detail. We are given the Cauchy problem, pq is equal to 1. We write it as pq minus 1 is equal to 0. Let f of x, y, z, p, comma, q is equal to pq minus 1. Right? We apply Charpit's method to find its solution. For that, we calculate fp. Fp means del f by del p is q, fq is p, fx is 0, fy is 0, fz is 0. The Charpit's auxiliary equations are dx by fp is equal to dy by fq is equal to dz by pfp plus qfq is equal to dp by minus in brackets fx plus p times fz is equal to dq by minus in brackets fy plus qfz. Right. Now fx is 0, fy is 0, fz is 0. From these 3, we get dp by 0 is equal to dq by 0. Right. Now taking each one of them and then integrating, we get p is equal to a, dp is 0, p is equal to a, dq is equal to 0. Integrating q is equal to b, where a and b are arbitrary constants. Now pq is equal to 1 will give you ab is equal to 1 will give you b is equal to 1 by a. Right. Now, thus we get p is equal to a and q is 1 by a. Agreed. Let's move to the next slide for the further discussion. The given initial condition is these conditions are given for s greater than 1. Now p naught, we evaluate p at x naught, y naught, z naught. It is a only because a is free from x, y, z. Q naught is also 1 by a. Therefore, P naught into Q naught is 1. That means A into 1 by A is 1. Now, thus, the possible initial strip is x0, y0, z0, p0, q0. x0 is s, y0 is 1 by s, z0 is 1, p0 is a, q0 is 1 by a. Right. These are the possible strips. This is the possible strip is this one. Let's look at our options. Now, in the option 1, a is 1 by a is 1 by s and 1 by a is s, and the product is 1. In option 1, p0 is a, q0 is 1 by a, p0 q0 is in this 1 by s into s is equal to 1. Option 1 is true. And in option 2, p0 q0, p0 is minus 1 by s, q0 is minus s, multiply, it is 1. Option 2 is true. In options 3 and 4, if you take p0, in option 3, p0 is 1 by s, q0 is minus s, product is minus 1. So also in option 4. So in options 3 and 4, p0 multiplied by q0 is minus 1. Options 3 and 4 are not true. So the possible initial strip are from option 1 and option 2. So the answer to this question is options 1 and 2. That is the detailed discussion of the solution of the given problem. And I am sure that this question is a very easy question. Right. Let's move to the next question. This is again from part C for 4.75 marks with this question ID. Right. And this is related to non-homogeneous wave equation. Let u, a function of x comma t, be the solution of dou square u by dou t square minus dou square u by dou x square is equal to xt, where x belongs to the open interval minus infinity to plus infinity, t greater than 0. And given the initial conditions, u at x comma 0 is equal to dou u by dou t, del u by del t of x comma 0 is 0. X belongs to the open interval minus infinity to plus infinity. Then to be evaluated u at 2 comma 3 is equal to, we are given 4 options. Right, these are the 4 options. Let's now discuss the solution of the problem in detail in the next slide. We have this equation, del square u by del t square minus c square into del square u by del x square is equal to f of x comma t, where x belongs to the open interval minus infinity to plus infinity, t greater than 0. Let's call this as the equation 1. And given the initial, suppose these are the initial conditions taken in a standard equation. U at x comma 0 is f of x, del u by del t at x comma 0 is g of x. Let these conditions be 2. Now, what is this equation? It is a one-dimensional wave equation. It is a non-homogeneous one. Why? F of x comma t is surviving here. If it is 0, it is homogeneous. F of x t is surviving, it is non-homogeneous wave equation. And for this, we have ready-made solutions. The D'Alembert solution is ready-made and it is given by u of x comma t is equal to 1 by 2 in brackets f of x plus ct plus f of x minus ct plus 1 by 2 c integral x minus ct to x plus ct g of s ds plus 1 by 2 c integral 0 to t integral x minus c into t minus tau to x plus c into t plus tau f of xi comma tau to be integrated with respect to xi and with respect to tau. With respect to tau. Right. So this is the well-known solution for that equation. Now, let's take our equation. Del square u by del t square minus del square u by del x square xt. X belongs to the open interval minus infinity plus infinity, t greater than 0. And u of x comma 0 is same as del u by del t at x comma 0. Both are equal to 0 for x belongs to minus infinity plus infinity. Comparing these, our given equations, with the standard equations 1 and 2, we obtain, in the place of c square we have 1, so c is equal to 1 we take. F of xt is xt, and u of x comma 0 is fx, but it is given as 0, fx is 0, so also g of x is 0. Right, with this one, we get into the solution and substitute here. So the solution is u of x comma t is equal to, f is 0, small f is 0, so this is all 0. G of x is also 0, this integral is also 0. So we are left with 1 by 2c, c is 1 by 2 into integral 0 to t into integral of x minus c is 1 multiplied by t minus tau to x plus 1 multiplied by t plus tau of f of, in the place of f of xi tau, it is xt, that is xi into tau, product xi into tau with respect to xi and with respect to tau. Right, that is equal to, first we integrate with respect to xi. So integral 0 to t 1 by 2 into integral 0 to t tau into xi with respect to d xi with respect to xi is xi square by 2 to be evaluated between x minus in brackets t minus tau to x plus t minus tau d tau. Let's move to the next slide for the evaluation. That's what we have so far. Right. So this is 1 by 4 integral 0 to t tau into, for the upper limit, x plus in brackets t minus tau whole square minus, for the lower limit, x minus t minus tau whole square whole into with respect to tau. Now this is a plus b whole square minus a minus b whole square. You know, when you evaluate, it is 4ab. So it is 1 by 4 integral 0 to t tau into 4a x b t minus tau d tau. That is equal to, the integration is with respect to tau, so x will come out and 4 will cancel. So x is equal to integral 0 to t in brackets, tau is getting inside the bracket and multiplying t tau minus tau square with respect to tau. This is equal to x into t into integral of tau square by 2 minus integral of tau square tau cube by 3 to be evaluated between 0 to t. And for the upper limit, x into t cube by 2 minus t cube by 3. For the lower limit, it is 0. And simplifying, we will get xt cube by 6. Now, what is wanted? We wanted u at 2 comma 3. So that means substitute x is equal to 2, y is equal to, t is equal to 3 in this, 2 into 3 cube by 6, that is 9. Now let's look at our options. Our answer 9 appears against option 1. Therefore, the answer to this question is option 1. So option 1 is true. The answer to this question is option 1. That is the detailed discussion of the solution of the given problem. And if you remember, the solutions of the wave equation, heat equation, and so on and so forth, and including the non-homogeneous one, if you remember them, the things will become very, very easy. Therefore, now prepare a very good notes for all these solutions, for all these wave equation, heat equation, etc. And that will be helpful in the examination. And I add a remark here that this problem can also be worked out in a different way, that is partial differential equations with constant coefficients and non-homogeneous one. Using that, you can do that. Agreed. We move on to the next question. That is the third question. This is from the section B for 3 marks with this question ID. And the question is related to number of solutions. The given question is the Cauchy problem y del z by del x minus x del z by del y is equal to 0. With the initial data, x naught of s is cos s, y naught of s is sin s, z naught of s is 1 when s greater than 0 has options. 4 options are given. Option 1, a unique solution. Option 2, no solution. Option 3, 1 but finite number of solutions. Option 4, infinitely many solutions. Let's now discuss the solution of the problem in detail. We are given the Cauchy problem y del z by del x minus x del z by del y is equal to 0. Right. With the initial data, this is the initial data given to us with s greater than 0. Now, the given equation is of the form pp plus qq is equal to r. It is a first order Lagrange's first order linear partial differential equation. To solve this one, we write down the Lagrange's auxiliary equations. dx by p is equal to dy by q is equal to dz by 0. In our case, it is dx by p. That is the coefficient of del z by del x, that is y is equal to dv by minus x is equal to dz by 0. Right. Take the first two. That is dx by y is equal to dy by minus x, and take the second and third, dy by minus x is equal to dz by 0. This will imply x dx plus y dy is equal to 0 and dz is equal to 0. Integrating, we'll get x square by 2 plus y square by 2 is equal to c1 by 2 and z is equal to c2. And this will give you integrating, we'll get x square plus y square is equal to c1, yes, cancelling the 2, and z is equal to c2. The general solution is obtained as c2 is equal to phi of c1, that is z is equal to phi of x square plus y square, where phi is an arbitrary function. And without using this initial data, many people conclude that there will be infinitely many solutions. They conclude it because they say their argument is phi is arbitrary function, therefore it takes infinitely many solutions. And they tick the fourth one. And they are right also. But the thing is, why this initial data is given? That's the question. So we use the initial data, then I will tell you how to conclude that it accepts infinitely many solutions. Right, that's what we have done so far. Using the initial data, z naught is equal to phi of x naught square plus y naught square. Z naught is 1, x naught is cos s, y naught is sin s. This will imply 1 is equal to phi of cos square s plus sin square s, s greater than 0. So, cos square s plus sin square s is 1. That will give you phi of 1 is equal to 1. Phi of 1 is equal to 1. Now, the solution is z is equal to phi of x square plus y square with the satisfying phi of 1 is equal to 1, where phi is an arbitrary function. Now, the question is, how many functions will satisfy phi of 1 is equal to 1? Here you look at this one. Phi of x is equal to nx minus in brackets n minus 1. N takes the values 2, 3, 4, so on and so forth. For all these things, for n is equal to 2, 2, 3, 4, so on and so forth, phi of 1 is 1. Substituting x is equal to 1 in this, they will give phi of 1 is equal to 1. So how many such functions phi will be there? As many as there are, at least as many as there are n is equal to 2, 3, so on and so forth. There are infinitely many solutions satisfying phi of 1 is equal to 1. Since there are infinitely many possible functions phi satisfying phi of 1 is equal to 1, the given partial differential equation has infinitely many solutions. Let's look at our options. Our answer that it accepts infinitely many solutions appears against option 4. Therefore, option 4 is true. The answer to this question is option 4. That is the detailed discussion of the solution of these three problems. And all these three problems are easy problems, and I'm sure partial differential equation, the section partial differential equation, from which 3 to 4 questions will come, and many a times they happen to be easy ones. At least some of them are easy. Right. I am sure that you have understood the solutions of these problems. Thank you for watching this video now. Please like and share my videos with your friends and colleagues. Please subscribe my channel if you have not already subscribed. We hope to meet you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.